Topic 10 is improper integrals. Two different types of integrals you'll typically come across on SIG test or on the AP exam. Most common, I think, are the ones that have limits to infinity, but you also may see one where it's undefined at an endpoint. So here are two pretty good examples. You can't write it as an integral going to infinity, so you have to write it as a proper integral by using limits. So I look at the limit as b approaches infinity of the integral from 0 to b of e to the negative x over 2. Take the antiderivative, you get e to the negative x over 2. Then I need to compensate. I didn't do substitutions, this is what I'm going to compensate. So to compensate for chain rule, which would have given me negative 1/2, I multiply by negative 2. Now I want to evaluate it. So I look at the limit as b approaches infinity of negative 2 e to the negative x over 2 going from 0 to b. So I do my upper limit first. As b goes to infinity, I get negative 2 times, I'll keep that separate, e to the negative infinity. Well, as e goes to negative infinity, it approaches 0. Then I do minus e to the 0. E to the 0 is 1. So I get negative 2 times 0 minus 1. That gives me a positive 2. The second example, I'm undefined at x equals 1. So I'm going to replace that with a. I look at the limit as a approaches 1 coming from above. Now, if you don't have this little plus right here, I'm not going to get too worried about it. Good chance to rewrite the equation as x minus 1 to the negative 1/2. Now I can go over and simply do my antiderivative, which is going to be x minus 1 to the 1/2, then times 2. Again, I'm going to evaluate it. So it's going to be going from a to 5. I plug in 5 first, and I get 2 times the square root of 4. Then minus, and I plug in the a value, which is 1. 1 minus 1 is 0. So I get 2 times the square root of 4. That's 2 times 2, which equal to 4. Key things I want to see. I want to see you guys write the limits of the original problem, and I want to see a limit written when you are evaluating it. If you're not sure about the e to the negative x one, what happens as x, when you're looking at as x approaches negative infinity of e to the x, the graph of e to the x, remember, looks like this. So as x goes to negative infinity, it's going to go to 0. That's because I'm going to plug in negative infinity into x, I'll get negative infinity. Or you can think of the graph of negative e to the negative x squared, or negative x over 2. It goes like this. As x goes to infinity, it goes to 0. And that's typically what you're going to see happening.